All right, we're back with Algebra 1, new Unit 6, Lesson 5. This is an extension of Lesson 4, where we are looking at equations where the linear system is going to be solved using elimination. But before you do that, you have to multiply the equations in order to make them, in a sense, compatible. So we're going to start by working out this first example, example number 2 from the lesson. So let me jump over here and start a new note here. 3x plus 4y equals 12. 2x plus 3y equals 9. So the main concept here is that, we want to eliminate like we did in the last lesson. But in order to do so, we need to get the coefficients of a pair of either the x's or the y's, the coefficients to be opposite. So the easiest way to think about this is that you want to multiply these by something so that when you're done, one of these will cancel out. So the easiest way to think about it is if I look at this 3x and this 2x, if I multiply the 3 by 2, and I multiply the 2 by -3, that will do the trick. So you can always multiply so that you get a positive and negative version of the same number. So here we're going to get 6x plus 8y equals 24. And then negative 6x minus 9y equals negative 27. So again, I'm just distributing this and this to each term. Now we're ready to add this up. And when I do that, these 6x's are going to cancel, leaving me with negative 1y equals negative 3. That's just me adding up those two equations. And then I divide by negative 1 on both sides, and I get y equals 3. I'm going to take that and I'm going to plug it into one of the original equations. So we'll just take the first one and we'll do 3x plus 4 times 3, plugging in the y, equals 12. 3x plus 12 equals 12. Subtract 12 from both sides. That cancels, giving me 3x equals 0. Divide by 3, obviously x equals 0. So the solution would be 0, 3. So you can see, again, I've been saying this every time, most of the working out is the same once you get past that initial step. So I'm going to just continue working out a few examples. That was number 1 up there. And then hopefully those examples will kind of give you what you need to get done with this lesson. And I'm going to introduce different kind of challenges you might come across along the way as we go through. 5y is 19 and not negative. X minus 2y equals negative 4. So this one's a little different in that I think you actually don't need to multiply both things. You can just multiply the second by negative 2. When you do that, you get negative 2x, which will match up with our 2x up here. I'm just going to bring this one over. Negative 2x plus 4y equals, again, I'm just distributing this negative 2, 8. And we're going to combine these two equations. Oops. Those are going to cancel. Might go back. It's a little thick. These are going to cancel each other out, leaving me with 9y equals, sorry, I made a mistake here. This was a positive 19. 9y equals 27. Divide both sides by 9, giving me y equals 3. Again, I'm going to take that 3 and I'm going to plug it back in up here somewhere. Doesn't matter. We'll choose the first equation again. Just tend to do that. Plug the 3 in for the y in the first equation. And then we're going to do 2x plus 15 equals 19. Go ahead and subtract 15 from both sides, just doing algebra here. 2x equals 4, divide by 2, x equals 2. So my solution would be 2, 3. Okay, so again, in that example, we only needed to multiply one of the terms because we needed it to match up with 2x and negative 2x. So that's pretty much it on that one. Next one, 4x plus 2y equals 14. 3x minus 5y equals negative 22. I think we need to multiply one of them twice. We need to multiply both of them is what I mean. I'll just do what I suggested earlier, which is to take one of the terms and just multiply by the opposite with one of them being negative. So we'll do 3 here and negative 4 here. So this one, just again distribute this 3. So it's going to be 12x plus 6y equals 3 times 14 is 42. Negative 4 times 3x is negative 12x, which is what we wanted. That's going to be plus 20y equals 88. Get some bigger numbers here, but that's okay. Everything works out the same. These 12s cancel out, giving me 26y equals 130. Divide both sides by 26. Again, all of this is the same type of process. And y equals 5. That y and plug it back in. 4x plus 2 times 5 equals 14. 4x plus 10 equals 14. Minus 10 from both sides. 4x equals 4. Divide both sides by 4. And we get x equals 1 or 1, 5 as our final solution. All right, let's see. I don't want to do too many examples because I think this hopefully will be getting into your head by now. Let's do one more where we have to do some rearranging. So let's say I have the following. 2x equals y plus 9 and 4y equals 3x minus 6. So in this, I need to do some rearranging. It's going to start off from a different point. So I need to get it into the standard form, right? I need it to be ax plus by equals c. So to do that, I need to, I'm actually going to move this guy down here out of the way. I need to move the y across, subtract y from both sides, and I get 2x minus y equals 9. That cancels out. And here I'm going to move the 3x across, and I get negative 3x plus 4y equals negative 6. And let's see here. Just line these up here. When I do that, it should be, hopefully you can see here that I can do the y's most easily by just multiplying by 4. So if I multiply this by 4, I'll get the following. 8x minus 4y equals 36. That means this is going to cancel, leaving me with 5x equals 30. Divide both sides by 5, x equals 6. I'm going to plug that back into one of these equations. I think the second one is probably the best option. So 4y equals 3 times 6 minus 6. That becomes 18 minus 6. 4y equals 12. Divide both sides by 4. And y equals 3. 6, 3 would be the final solution. All right, so those are a bunch of examples of how to do elimination with multiplication. But I want to say something before I kind of close out. Looking at the lesson really briefly, you've got a bunch of these examples. You've got all of these here. So just do those problems. Remember, go back to the very beginning of the lesson if you need to remember what to do with no and infinite solutions. That's from lesson 1 and 2. Get all the way down, number 7, number 8, all of these are the same. It just uses h and k instead of a and b or x and y. And then it has you set up some equations. I'm going to go ahead and help you set these up real quick. So let me open a new drawing. And for this number 11, it says at lunch, Mark bought 2 quesadillas and 2 tacos for $10.16. Quesadillas are x, tacos are y. So 2 quesadillas would be 2x, and 2 tacos is 2y. Together, those cost $10.16. Jason bought 5 tacos and 1 quesadilla. So 1 quesadilla and 5 tacos, and it cost him $11.84. And then you have to solve. And I'll go ahead and tell you, to get you started on using elimination, you need to multiply the second equation times -2. You do that, you'll be able to eliminate one of your variables. Let's look at number 12. Use the scenario and elimination. This one, you don't need me to get you set up. You already have the 2 equations here. There's equation 1, there's equation 2. You need to, again, find the solution. I'm not going to work on number 12 with you, but I will look at number 13 with you. So change this to number 13. Your math teacher is planning a test for you. The test will have 30 questions. Some of the questions will be worth 3 points, and the others will be worth 4 points. There will be a total of 100 points in the test. How many 3-point questions and 4-point questions will be on the test? So we need to know how many 3-point questions and how many 4-point questions will give us 100 points. So we know there are a total of 30 questions. And we know that when I do x will be 3-point questions, 3 times x, 3 times the number of 3-point questions, plus 4 times the number of 4-point questions will give me 100. Those are your 2 equations. Hopefully you know this, but just to get you started, I would recommend multiplying equation number 1 times -3. And then those will cancel out for you that way. All right. 14, similar situation. I'll help you get set up. She has 40 coins in total, Q and D, quarters and dimes. Quarters plus dimes equals 40 total coins, and the total cost price of them is, or value of them is $6.25. So 0.25 times quarters plus 0.10 times dimes gives me that. And then you solve that way. Lots of questions in this lesson. Let's look at Beethoven's ice cream shop. All of their ice cream cones were $2.50 each, and their sundaes were $4 each. At the end of the day, the manager counted the total number of items at 225. C and S are our values, so there were 225 total cones plus sundaes sold. We also know that cones are $2.50 each. So $2.50 times the cones. Sundaes are $4 each. 4 times the sundaes equals, and they made $675 on that day. So there's your two equations. Just to get you started, I would recommend multiplying equation number 2 or equation number 1 by -4. All right, so that gets us through all of these different solving linear systems problems. And now I want to pause for a second to just remind you that at the end of the day, I want you to focus on getting the right answer whatever way you like best. So I appreciate that you have watched and tried to attempt these problems alongside me in the videos. And I do want you to know to some extent how to solve in these various methods. Having said that, and I will use one of these as an example. I'll use the example of someone we've already done. If I wanted to solve example 2, which was the first problem I did in this video, I can use a graphing calculator to do that really easily. So if you go to the Desmos calculator and you put these equations into y = form, you can graph those and solve and find the solution that way. Let me show you what I mean. Let's write these equations down again. 3x plus 4y equals 12. And through 2x plus 3y equals 9. Remember that to solve equations for that form, you need to do two things. You need to move the x and second step, divide the y. What that means is to move the x means to move 3x across. 4y equals -3x plus 12. Over here, I'd move 2x across, leaving me with 3y equals -2x plus 9. And I divide everything by 4. And over here, I divide everything by 3. So my two equations would end up being y equals -3/4 x plus 3 and y equals -2/3 x plus 3. So if I go to graph these two lines on my graphing system, I type y equals -3/4 x plus 3 and y equals -2/3 x plus 3. Go back and make sure I got those typed in right. I can see that they intersect at the point 0, 3. And so instantly, because of that, I can say that is the solution to these equations. So I could easily have just gotten that 0, 3 is the solution to those two lines. So graphing is always kind of a backup method for you to use. And if you'll notice, we got the same answer when we did that over here. We did this by hand, we got the answer 0, 3. So I just want you to remember you have all these options at your disposal and use the ones that you feel like that you're the most confident in. But that's it for using elimination. So please reach out to me if you have questions or if you need more examples to work out, or if you need me to check over a quiz or anything like that. Sign up on the Open Tutoring Sheet, reach out to me by chat or by email.